This is homework help for worksheet 10 continued. So we're going to be looking at composition in this video. I assigned 4, 8, 13, and then 15 and 16 were parts that were done in class, okay, or should have been done in class. So I'm going to go ahead and go over a few of those. Let's see, so we have 13 here, 4, let's see, we also had, I said 8, and let's see, 15 and 16. I'm thinking 15 and 16 are probably the best questions to go over, but I'll also go over one from the front side. Okay, so let's look at number 4. So with number 4, you are asked to find the composition of H with G. This notation means that I have a function H. Sorry, I didn't mean to put that in parentheses. I have a function H, and I'm going to insert the function G into that function of H. Okay, so I have to look at above to see what the function is for G, and the function for G is x plus 2. Grab a highlighter there. Okay. So I'm going to, here where I see this G of x, I am now going to insert this x plus 2, or x minus 2. So that means that I'm going to insert x minus 2 wherever I see an x in the function of h. So I need to figure out what h is. H is up here in the directions again. And so I have h of x is equal to square root of x. And so this notation means that where this x is here, I'm going to plug in this x minus 2. So the square root will still be there, but inside the radical will be the x minus 2. Now here we don't have anything to simplify really, because I don't have a product that I can square root. I have the difference, and I can't square root either of those. So this is the final answer. And then I need to go back and look at my instructions. It says find the domain for the result for numbers 1 through 5. So the domain is, we go back and we think about, well, what is this function family? It is a square root, and square roots have a domain that is not all reals. To find that domain algebraically, we take the radicand, or the value inside the radical. That's x minus 2. And you set it greater than or equal to 0. And the reason we do that is because in a square root, if we have a number bigger than 0 inside here, I can square root it and get a real number. But if I have any value smaller than 0, I would get an imaginary number. So like a number smaller than 0 would be -4. If I square root a -4, I get a 2i, which is imaginary. Okay, and we only want real numbers. So to solve this equation, I can add 2 to both sides, and I get x is greater than or equal to 2. And so I'm going to add that down here. And that is my final answer. Okay. Let's see, I think we should probably also go over one on the back. So let's see, 15 or 16. I'm thinking that 16 might be the better choice right now. So I'm going to look at that number 16. Okay. And we see f of g here. So f is this function here, and g is this function here. So this means that I'm going to take the function of f, and I'm going to insert the function of g into the f. Okay. Well, we know what g is. G is the square root of x plus 4. So I'm going to put that in this place, just using direct substitution. And this came from this part up here that was given. Now I can interpret this as, well, okay, well, in the function of f, I'm going to put this square root of x plus 4 wherever I see an x. So I have an x right here. So in that spot right there, I'm going to plug in the x plus 4. The rest of it stays the same. I still have a 3, I still have a square, but in that place where the x is, I need to plug in square root of x plus 4. And again, that came from this function of g. Okay, so now we just have to simplify it. When you simplify, you're using order of operations. And please excuse my dear Aunt Sally is the acronym, or sometimes we call it PEMDAS. So we look to see, is there anything to do inside the parentheses? There's a square root. I cannot add the x and the 4. I cannot square root it, so the parentheses is done. Then I look at exponents. I do have an exponent, and so now I'm going to square this value. When I square a square root, the square root drops off, and I'm left with just 3 times x plus 4. And you could leave your answer in this format. This would be factored form. But you could also distribute it. And so if you distribute the 3 times x is 3x, and 3 times 4 is 12. Both of those answers are correct. Okay, I will accept either one for full credit. This is worksheet 10. I hope you found this helpful. If you have any questions, please come see me during office hours.